Hello students. So in this video I'll give you introduction to graph theory. So what is a graph? A graph is a diagram consisting of collection of vertices together with edges. So what is actually a graph? Graph is just a diagram. You put some dots and you join them with lines and that becomes graph. Okay, and the graph is mathematically written as G equal to G V comma E, where V is the set of vertices and E is the set of edges. Okay, like see in this example, here you can see there are some points A, B, C, D, okay, X. There are 5 points. So these points are what? These points are vertices. Points are vertices. Okay, so set of vertices are A, B, C, D and X. And there are lines which are joining these vertices. A is being joined to B with an edge E1. Okay, B is being joined to C with an edge E2. Okay, B is being joined with D with an edge E5. Okay, so these all are edges. So these the set of edges is denoted by E. E1, E2, E3, E4, E5, E6, okay, and E7. This is a loop, okay. These all are edges. The set of edges is E and set of vertices is E, and this is a graph. And mathematically we write graph as G equal to VE. And what is graph? Graph is just a collection of vertices and edges, okay. So now what are directed graphs? So in a graph, if we give direction to the edges, okay, here see I have given direction to this edge that E1 is going from A to B, E2 is going from B to C, E3 is going from C to A, okay, E4 is going from A to C, E5 is going from B to D, E6 is going from D to C, E7 is going from B and it's coming back to B. So such kind of graph in which all the edges have some direction. Okay. Now it can happen that it can go from here to here also, from B to A also. Okay. So such kind of graph in which the edges have direction. Okay, here we have direction. So such kind of graphs are called directed graphs. Okay, so let's see some basic terms which is used in graph theory. The first one is edges and vertices. Two vertices are adjacent if there is an edge connecting those two vertices. Okay, so if I see here edge A, between A and B I have an edge E1. Okay, between A and C I have an edge E4. So whenever between two vertices we have edge, here we have edge, here we have edge, then those two vertices are called adjacents. When there is a no edge between two vertices, then those two vertices are not adjacent. Like here you can see A and D, A and X. There is no edge between A and X, no edge between A and D. So they are not adjacent vertices. Loop, as just I have told you, an edge which starts and ends at same vertex. Here you can see E7. It's starting from B and it's ending at B. So such kind of edge is called a loop. Next one is isolated vertex. A vertex which is not joined by any other vertex by an edge, it's called isolated vertex. Here in this diagram you can see X is not being joined by any other vertex, right? Then such kind of point which is lonely from the other vertices, such kind of vertex is called isolated vertex. Okay, parallel edges, if two edges have same end vertices, okay, they are called parallel edges. Here in the example you can see this edge E3 and E6, both these two edges have same end vertices. Okay, they are ending at D and C. Okay, so such kind of vertices are called such kind of edges are called parallel edges. Then adjacent edge, if two non-parallel edges have one common vertex. Here you can see this A, B, B to C. Okay, so these are E1 and E2 are adjacent edges because there is a common vertex here. Okay, between E1 and E2 I have a common vertex B. Here also you can see between E5 and E3 there is a common vertex D. So E5 and E3 are also adjacent edges. Next types of graph. Simple graph, a graph which has neither loop nor parallel edges. Okay, if there is no such edge which starts from one point and ends at same point. Okay, and if there are no such edges which have the same endpoints, then that graph will become simple graph. Here you can see there is no loop, there are no parallel edges, so this is a simple graph. Here also you can see there is a no loop and no parallel edges, so this is also a simple graph. Next is journal graph or multi-graph, a graph which has either loop or parallel edges. Okay, here in this graph you can see there is a parallel edge, here is a loop, so this is a multi-graph. Here you can see there is a loop, so it's also a multi-graph. This is complete graph, a graph in which there exists an edge between every pair of vertices. Such kind of graph is called complete graph, and this complete graph with the n vertices is always denoted by kn. Okay, here you can see there are two vertices in the first example, so they are connected between they are connected by one edge. Okay, here in the second example you can see there are three vertices. All these three vertices are if you see the first vertex here, the first vertex is attached to other two vertices, the second vertex here is attached to other two, the third vertex here is attached to other two. Okay, so in complete graph every vertex is attached by other pair of vertices by some edge. Okay, here you can see every vertex is attached to other three vertices. There are four vertices and every vertex is attached to other three vertices. Here also every vertex is attached to other four vertices. There are five vertices there, so every vertex is attached to other four. As you can see here, this vertex is attached with this, is attached with this, is attached with this, is attached with this. Okay, so such kind of graph in which every vertex is attached to other vertices by some edge, that kind of graph is called complete graph. Next is a weighted graph, a graph in which each edge is assigned a number or weight. Such kind of graph is called weighted graph. So if I assign that this edge has weight 1.5, if I assign that this edge has weight 1.8 and so on, all the edges have some weight in them, then such kind of graph become weighted graph. Next is order of a graph. Number of vertices in graph is called the order of the graph, and it is denoted by mod of Vg. Then trivial graph, if I have only one vertex and no edge in the graph, then such kind of graph is called trivial graph. Now let's see what is the degree in a directed graph. Okay, so in directed graph we have in degree and out degree. Okay, so what is in degree? In degree means the number of edges which are coming towards one particular vertex. Okay, we'll see, if we have one graph, we will take one vertex and we'll see the degree of that vertex. Okay, we'll see the number of edges which are coming towards that vertex, that will become its in degree, and out degree the number of edges which are going away from that vertex, that will become its out degree. For example, if you see in this graph, if I have to see the in degree of A, okay, number of edges which are coming towards A. Okay, there is no edge which is coming to A. This E1 is also going away, this E4 is also going away from A. So in degree is always denoted by degree G plus A. Okay, so there is no in degree, there is nothing coming to A, so in degree is 0. And out degree here is 2, so because 2 edges are going away from A. Okay, if I see for B out degree 1, 2, out degree is 2 and in degree is 1. If I see for C in degree is 1, 2. Okay, and out degree is also 2. There are 2 which are going out of this. Okay, then for C we have seen. For D For D, if I see, for D I have in degree 1, 2 and 3. There are 3 and there is no out degree, nothing is going outside this. Okay, and a vertex with in degree 0 is called source. Okay, so whenever you have in degree to be 0, whenever there is nothing coming inside a vertex, then that is called source, and a vertex without degree 0. Okay, so if there is nothing coming outside the vertex, then that vertex is called sink. In above example, A vertex is source because everything is going out of A, and D is sink because everything is coming inside D. Okay, source is something from which something originate, right? So here also, if you see, A rays are coming out, like sun is a source of energy. Okay, sun is a source of light, so rays goes out of sun. Here also see rays are going out of A. Okay, and sink is something which attracts everything, so it's attracting. D is attracting. Okay, so everything is going inside D, so that's called sink. So this is the directed graph, degree in a directed graph. Then degree in graph in any directed or undirected graph. So degree of a vertex in directed or undirected graph is the total number of edges incident with it. Okay, so whatever be the total number of edges incident to that particular vertex, that will become its degree. Like if you see for this A, how many edges are incident? 1, 2 and 3. So degree of A is 1, 2, 3 and 4. 4 edges. So degree of A is 4. If I see for B, 1, 2 and 3. So degree of B is 3. For C, 1, 2, 3. And here you see loop is there. So loop is going outside and coming back. So it will be considered as 2 edges. Okay, it's going outside and coming back. So 1, 2, 3, 4 and 5. Degree of D, 1, 2, 3 and 4. So degree of D is 4. Okay, in directed graph, degree is also always equal to in degree plus out degree. Okay, I have calculated here. You can see for directed graph or undirected graph, degrees are equal. Next, what is pendant? A vertex whose degree in a graph is 1. Okay, such kind of graph is called pendant. When the vertex has only 1 degree, means it is attached with only one edge. Such kind of vertex is called pendant vertex. Like here A and C, they are pendant vertex. Their degree is 1. Now, what is K regular graph? A graph in which all the vertices have same degree equal to K. Such kind of graph is called K regular graph. Like here, you can see this is one regular graph. Degree of A is also 1. Degree of B is also 1. Okay, so this is one regular graph. Degree of A here is 2. Degree of B is also 2. Degree of C is also 2. Degree of D is also 2. So all the vertices have degree 2. So this is 2 regular graph. Here you can see degree of A is 1, 2, 3. Degree of B is 1, 2, 3. Degree of C is 1, 2, 3. Degree of D is 1, 2, 3. Degree of E is 1, 2, 3. And degree of F is also 3. So this is 3 regular graph. Similarly, here you can see all the vertices have 4 degrees. So this is a 4 regular graph. So this is the basic of graph theory. Listen to this video carefully. If you have any doubt, you can ask me anytime. Okay, thank you for watching this video.